In previous lessons, we examined the answers to what happens when we study, why can we remember, and why do we forget. In this lesson, we'll look at how should we study, given what we know about the brain. We're going to use two graphs to follow the course of a student studying. We've associated the retrieval strength with the short-term memory system, the working memory system, and storage strength with the long-term memory system. So over time, as a student is studying, we're going to look at how these quantities change. And we'll encounter some misconceptions that students have about studying, and then we'll develop a list of best practices to maximize the effectiveness of our study. So in the beginning, when we start our study process, we of course are increasing our retrieval strength as we process the information. And that will then have some marginal impact on our storage strength. We're making changes in memory systems to store the information that we're studying. Unfortunately, students often mistake retrieval strength for storage strength, and they stop studying, and then they don't retest. So when students have developed high retrieval strength, they can make a mistake and then conclude that because they have high retrieval strength, they must also have a high storage strength. And that is a mistake, because with the first study session, the high retrieval strength is going to be due to the working memory boost. We have yet to do systems consolidation, so we have only a marginal impact in the storage strength. Now, it is true that after studying, there will be some hippocampal replay, and the cortical memory traces will start to show an increase. But again, we haven't gone to sleep yet, where much of the system consolidation is happening here. So if we're just studying, we haven't yet made all of the gains in storage strength that occur during sleep. This leads us to misconception number 1. We think we know it because we can easily retrieve the information during study sessions. The reality is that easy retrieval is the working memory boost, not strong storage strength. Understanding is not the same as remembering. Now, because we have low storage strength, it means that we're going to have fast forgetting. So forgetting is the loss of retrieval strength. So we're losing access to the information, and it's a steep slope here because we have not boosted storage strength very much. In general, then, one of the misconceptions students have is that they underestimate how fast they will forget. In addition, students often think that prolonging a study session will do them good. But prolonged study sessions with high retrieval strength is not effective. It becomes less and less valuable. There's very little gain in storage strength when we continue to study when we already have high retrieval strength. This leads to misconception number 2. We think that long study sessions are good. In reality, biology puts limits on the value of continued study. Now, why don't long study sessions enhance long-term memory? Well, let's just think about what a study session is. We're going to be reading some text. Our cortex will process the information, send it into the working memory system. What's in working memory can be written into the long-term memory system by way of the hippocampus. The hippocampal memory traces involve synaptic plasticity. A subset of those hippocampal neurons will be allocated to the memory trace. Synapses will increase in strength, and this is the memory for the specific text information that we were reading. The problem is that when we have high retrieval strength, because we've just been reading the text, during the same study session, the hippocampus memory trace cannot be strengthened with further study. It has reached a biological plasticity limit. And we saw this in earlier lessons, the idea that when we learn, we increase a certain set of synaptic strengths here, but that means that those synapses are unavailable for new learning. There's a maximum amount that they can be enhanced. If we look on the left here, the idea is prior to study, we have weak synapses in the hippocampus. We study some new material. Certain synapses are strengthened. That represents the learning. But if we continue to study, we cannot increase those synapses anymore. So misconception 2 is that we think that long study sessions are good. The reality is when retrieval strength is high, further study becomes less valuable. And now we can kind of see what we mean by retrieval strength is high. Well, we've already initiated synaptic plasticity at the relevant synapses here. And that's what's making the information quickly accessible. The problem is we can't strengthen those memory traces at this time. So synapses in the hippocampus have reached a maximum strength for that information. Further study cannot strengthen synapses anymore. And the implication is long study sessions lose their effectiveness over time for biological reasons. Now, if we do stop studying, of course, and then go to sleep, sleep results in lower retrieval strength due to the delay. And the working memory boost will be gone. So the next morning we're going to have lower retrieval strength for the material that we just studied the night before. However, sleep is also involved in system consolidation. So consolidation processes are going to increase the storage strength. And remember, that involves the hippocampus signaling the cortical memory traces to strengthen the connections between allocated neurons. So we have two effects here. We have a loss of retrieval strength due to the delay. We lose the working memory boost, but we should have an increase in retrieval strength due to the increase in storage strength. Now, briefly, why does sleep enhance long-term memory? We learned earlier that during sleep, the hippocampus replays those memory traces that were involved in the day's learning. So sleep helps to consolidate the cortical memory in the long-term memory system. Here we have the hippocampal changes during learning, and then the memory trace in the hippocampus will be replayed so as to strengthen the memory traces in the cortex. But we also learn that sleep has another effect. Sleep resets the hippocampus in preparation for new learning. Synapses are weakened in the hippocampus so they can be strengthened again for new learning. The hippocampus is a fast-acting, limited-capacity memory system that needs to be refreshed for continued learning. Notice the arrows going the other way. So during sleep, two processes are happening. We're getting system consolidation to strengthen cortical memories from recently learned information, but then we're also resetting the hippocampal synapses so they're capable of sustaining new learning. And we called this a sort of a danger of synaptic saturation. Those synapses involved in learning are unavailable for new learning. So sleep is going to weaken synapses in the hippocampus so they can be reset and then sustain new learning. Now again, that we can connect this up to the ineffectiveness of long study sessions. Long study sessions get less effective because synapses must be reset for new learning during sleep. If we keep on with the same study session, we are going to encounter the maximum plasticity limit here. We have to undergo the system consolidation during sleep so we can then also reset those synapses in preparation for new learning. Now, in the language of the psychology folks, sleep enhances storage strength due to system consolidation, so retrieval strength will be increased due to the strengthened synapses in the cortex. However, sleep is also a delay, so the working memory boost is gone and retrieval strength is diminished. And this explains why you might not remember the information from the previous night's study session. Even after the memory enhancing effects of sleep, you've lost the working memory boost, and the long-term memory was not yet strong enough for successful retrieval. Now, repeated study sessions spaced out in time, including sleep in between those study sessions, will increase storage strength. And as the long-term memory strengthens, sleep will no longer lead to forgetting. So in time, sleep will no longer lower the retrieval strength because we will have boosted the storage strength to a sufficient level that we can retain our access to the information even after the delay from sleep.